Today's lesson is on 8M1, lesson 7. We're going to talk about magnitude. We're going to be building on our building blocks of exponents and what we know about exponents, and we're kind of leading into the unit on scientific notation. I'm going to give you some keys and some tips and some problems involving magnitude, and then give you some homework help at the end. Feel free to use this video any way you like. If you just need help with the homework and you understood the lesson, fast forward to the end. If you want to have a few extra problems, follow along. I'm going to start slow and ramp it up. All right, let's get ready to rumble. Let's go. Okay, so let's start off over here with a few problems. We're going to learn about, or we're going to remind ourselves what powers mean. What does 10 squared mean? 10 to the second power, 10 to the fourth. We're going to do some negative exponents. Now remember, or interestingly enough, we're going to be dealing pretty much with powers of 10 today. We're going to, when we talk about magnitude, we often talk about powers of 10. So we're not going to be looking at x to the second, x to the ninth, or 4 to the 42nd, or 4 to the -2. It's all going to be pretty much, we're going to stick to, bases of 10, right? This is our base, and this is our exponent. The whole thing together is a power. So remember, 10 to the 2 simply means 10 times 10, which equals 100. 10 to the fourth is 10 times 10 times 10 times 10. And if you multiply all of that out, you get 10,000. I'll let you do the math on that. You should be able to do your multiplication. 10 to the first is just 10. So notice this is key. This is key here. The number of zeros equals the power, or equals the exponent. For positive powers of 10, right? Here we have 10 to the 2, so we have our 2 zeros. 10 to the fourth, so we have 4 zeros. And 10 to the first, we have 1 0. And that's just the way it works out. It's not some rule, or it's not some definition, but it is a rule. So 10 to the 0 is interesting. We have, it's by definition, if you go back to our zero exponent chapter lesson, that's just 1. So it's 1. And notice there are no zeros, no zeros. Put a box around it, a 1. We can box our answers here just for fun, because our teachers are going to like that. Your teachers are going to love it when you box your answers, committing to a solution. Now, 10 to the -2, remember our negative lesson, our negative exponent lesson would say, well, that's the same thing as 1 over 10 to the 2, which is equal to 1 over 100. And 1 over 100, if you write it as a power, or sorry, as a decimal, that's 1.01, or sorry, 0.01. And 1 over 10 to the -4 is 1 over 10,000. And so that's 0.0001. Now notice here that the number of if you want to try and think about this in terms of a rule, which I kind of discourage maybe right off the bat, but if you want to, it's going to be the same number. If this is a -2, you're going to have only 1 0 after the period, after the decimal. And if it's a -4, you're going to have 3. So it's 1 less than the exponent, if you will, after the decimal between the 1. So 10 to the -6th, which is equal to 1 over a million, 6 zeros. There'll be 6 zeros here. Notice this will be 6 zeros. But here you're going to have 5 zeros after the decimal. 1, 2, 3, 4, 5. This will be 5 zeros. After the decimal. Okay, so there we go. Here's kind of we'll just leave these sitting over here for reference because we might use these in some of our other problems. So now the second, so this is that's kind of the first thing. This is 10 to the second equals 100, 10 to the 0 equals 1, 10 to the -4 is 0.0001. Now the second thing I want to show you is how to find, now this is going to be, let's use a different color. Let's go to orange. Let's say find, or reddish orange. Find the powers. Find the power of 10 just greater than a number and power of 10 just less than a number. Okay, so there's a lot of problems in today's lesson that are like this, and the key is going to be like, watch. So we're going to say we want the number that bracket. It's kind of like the powers of 10 that just bracket. I'll call it bracket a number. So if we looked at the number 987, so this is problem A. Bracketing 987, we want a power of 10 just greater than this number. So this is going to be a number that looks like this, a 1 with a number of zeros after it, and is bigger than 987. So let's just write this number here, 987, and let's try and find a number that's bigger. We want a number that's bigger to go here. Well, let's look at that. Is 1 bigger? No, 1 is not bigger. So maybe is 10 bigger? No, 10 is not bigger. 987. How about 100? Is 100 bigger? No, 100 is not bigger than 987. So we got to go to 1,000. Is 1,000 bigger? Yes. Well, 1,000 is bigger. And you end up, with a number that has just 1 extra digit than the number that you're looking at. So this is going to have like 1 extra digit. That's kind of our key. And you can just test this out. I mean, this is the rule that I might use, but you just kind of just write it out. And if this has, 3 digits, this is going to have those same 3 digits with zeros, but then I'm going to have this extra digit that is greater than the number of digits here. So this is our thousands place. So in this number, there are no thousands. This is kind of a zero, or that's a zero right there. So if 1,000 is just bigger, then the number that's going to be just smaller is going to end up being just 100. It's going to have 1 less 0. And now and this is just smaller. So now I have 2 powers of 10 that are bigger and smaller than 987. And so 1,000 is, by rule, right? This is 10 times 10 times 10. This is 10 cubed, 10 to the third, and this one is 10 squared. So I can say that 1,000 is bigger than 987. Whoops. What am I doing? 1,000 is greater than 987, which is greater than 100. Or alternately, 10 to the third is greater than 987 is greater than 10 squared. And that's kind of the object of a number of problems in today's lesson. So let's open up, and so let's just give ourselves we'll give ourselves a happy cat for that. Happy cat, happy cat, happy cat. And we're going to go to another problem that's similar. And we will go back and we'll try and find the numbers. Let's see, let's do the number, or the powers of 10 that bracket 42,123. Now you try. If you think you can do it. And you try here and pause. And we're going to use the same method that we just used on the last problem. Now I'm assuming you're back and you're ready to go. Hopefully you tried it. And we're going to use that same method. We're going to say, well, 42,123. And we're going to find the number that's just bigger. And that's going to be, well, is it going to be 10,000? It will definitely, it's going to have these zeros here. But it's not going to be 10,000 because that's not bigger. 42,000 is bigger than 10,000 because it's got a bigger number in the 10,000s place. So we need to put a 0 here and we need to add a 1. And now this number is definitely bigger because it has a number in the 100,000s place, and this one doesn't. So this number, and so the number that's just smaller is going to be 10,000. And so if this number is just bigger, it's 100,000. So we can say that that's 10 to the 5th. 1, 2, 3, 4, 5 zeros. 10 to the 5th. And smaller is 10 to the 4th. So let's write our answer and say 10 to the 5th is greater than 42,123, which is greater than 10 to the 4th. Now let's box that answer. Now let's look at one that's less than. Now notice we're going to take a number that's now less than 0, or less than, this is less than 1, right? This is greater than 0 because it's a positive number, but it's less than 1. So we got to find a number that's between, what number is this between? Now what powers of 10 is this between? Now, let me put it in a different color here. So let's go, well, is this number greater than, which number's bigger here? We're going to use the same technique that we used above. Well, well, that number's not bigger because this number here are hundredths. This one is 0.0417 is bigger than 0.00110. So because it has 4 in the hundredths digit, and this has 0. So that's not going to work. So how about this number? Well, this number is not bigger because, again, in the hundredths spot, the 417 has a bigger hundredths spot. So I need to now take a 1 and put it in this spot. Remember, the whole trick is this number has to be a power of 10. And so it can only have a 1 and zeros. It can't have anything else. It can only have 1, 1. It can have 1, 1. And the rest have to be zeros. So this number is bigger than 0.0417 because it has a number in the 10th spot, and 0.0417 has nothing in the 10th spot. So this number is definitely bigger. So if that number is bigger, then this number is just smaller. Right? Because our orange number, or our tan number here, has a 4 in the hundredth spot, and this number only has a 1 in the hundredth spot. So this number is definitely bigger. So 0.01, this number is equal to 1, it's a tenth, which is equal to 10 to the minus 1. And this number then must be 10, just next to it must be 10 to the minus 2. And that's true because this is the hundredths digit. So our answer here then is 10 to the negative 1 is greater than 0.0417, which is greater than 10 to the negative 2. We'll do another one of these when we do the homework helper, but I want to keep moving on and make just a really quick point that I've made before, but let's revisit it here. Right? And that is that, right, 10 to the third is 1 with 3 zeros, right? If positive power of 10, you just have, it equals a 1 with the exponent number of zeros after. All right, so this has 3. So this has 3 zeros. 10 to the 8th equals 1 with 8, 2, 3, 4, 5, 6, 7, 8. Right? Negative power of 10 equals 0 point with 1 less 0 than the power followed by a 1. So 10 to the negative 2 equals 0 point, and then I have to take 1 less than the absolute value of this negative 2. So we take a 0 and then a 1, right? This is equal to, 2, the absolute value. The absolute value of negative 2 is 2, but I have to take, 1 less than 2 zeros. So 10 to the negative 5 would equal 0 point, and now I need 4 zeros. 1, 2, 3, 4, and a 1. And 10 to the negative 10 would equal 0 point, and then I need 9 zeros. 3, 4, 5, 6, 7, 8, 9. Okay. So hopefully we get that happy cat. Happy cat, happy cat. And then we're going to move right along. And we're just going to go right now into problem set, because this lesson is, you've mastered it by now. So I want you to show me that you've mastered it. And so now I'm going to do problem set. I'm going to type this up. Let's look at this. Let's see. Oh, there's a guy here. Watch this guy. Where is he? Oh, he's going to focus. He's going to focus. He's not a mean guy. He's just, well, maybe he is. But he's just focusing on a problem. This is like a little bug. He's focused. Maybe that doesn't work for you. I don't know. Okay, so in this problem set, we're going to find two things, 2 questions. Just 2 questions. We want to bracket. We want to find, I'm going to call this bracketing, which is, and we talked about this in the lesson, but if you didn't listen to the lesson, then I'm going to explain it. Find the smallest power of 10 that is greater than the number. I'm not going to give you that number here in a second. That's A. And then B, find the greatest power of 10 that is smaller than the number. Okay, so our first number here is going to be, and so watch this. So our first number is going to be 59,623. And so we want to find a number that's bigger and smaller. All right, a bigger number there. And then over here, we want to bracket the number 0.0004. Now we'll use a different number. We'll use 8, 2. And so we need a bigger, and these have to be powers of 10, not just any bigger number, but the power of 10, just bigger and just smaller than these numbers. So I'll let you try. So now you pause, plus try. Okay, so I'm assuming you're back now, and let's just look. So again, our bigger number is going to be, we have to fill out our zeros. 0, 0, 0, 0. And does that work? No, 10,000 is not bigger than that, so we need to go one more 0. And so the number just smaller is going to be, and that's 10 to the 5th. Right, 5 zeros. And this number that's just smaller is going to be 1 less. It's going to have to be 10 to the 4th. If this is 10 to the 5th, the one just smaller is going to be 10 to the 4th. We can kind of do it backwards even. So that's going to be this one. And so the way I like to write the answer is 10 to the 5th is greater than 59,623 is greater than 10 to the 4th. And over here, we got to go, 0.000. Well, no, that number's not bigger. So this number here is going to be just bigger. And smaller is going to be 0.000. It's going to be 1 digit to the right, or my one digit to the right of my bigger number. So that number is just smaller. So this is 10 to the negative 3. And this is 10 to the negative 4. Right, this is 2 zeros, and then when I'm dealing with negatives, I have to have an extra negative. It's got to be, it's not negative 2, it's going to be negative 3, because that's what we do when we're on the right side of the decimal. And the way, again, remember, this is 0.1 is 10 to the negative 1. So 0.01 is equal to 10 to the negative 2, and then 0.001 is 10 to the negative 3. If you ever forget the rule on the negatives, or with the decimals that are less than 1, you can just kind of write it out, and then you can figure out the rule for converting between decimals and powers of 10. So our answer over here would be 10 to the negative 3 is greater than 0.00082, which is greater than 10 to the negative 4. All right. If you got that right, give yourself a happy cat. Give yourself a happy cat. We can spin our, whoa, you can make him skinny and a little plumper, and we can spin him around. Okay, great. We're going to now return to just summarize what we've learned. And so what did we learn? We learned how to convert between decimals and powers of 10. We learned how to bracket numbers that are greater than 1 and less than 1. And that's pretty much it. This is pretty much the primary building block that we're going to need for dealing with scientific notation, which is the way almost all scientists represent numbers. Very powerful, very relevant concept. So when you're over there in math, in science class, after the next lesson, you're going to be a whiz at scientific notation. All right, I'm going to sign out here. Great talking to you. Good luck. Happy cat with your math. We'll talk to you with the next lesson. Bye. Have a great day.